Okay, welcome back. So let's pick this up right where we left off. So again, this situation, like we mentioned, we're going to let x be the number of price changes. So let's keep that in mind there. So remember now, if we're trying to look at profit, trying to create an equation for profit here, remember that profit is revenue minus costs. Okay, that's our basic equation for profit. Now, revenue is price times number sold. Okay, and then of course we have our costs as well. So remember, this is what we're trying to use to sort of just set up our equation. Now, remember doing this a little bit in grade 10, but if not, let's just take a look at our price here. So we start off selling the mushrooms at $15 per pound. Okay, so we start off selling them at $15, then every time we change the price, it's a $2 increase. So it's 15 plus $2 for every increase or for every x. So it's 15 plus 2x for the price. Keeping on with that, for our number sold, we start off selling 1,600 pounds of mushrooms. And every time we change the price, we lose 100 pounds in sales. So we're going to go 1,600 minus 100 for every x for every price change. So that right there gives us our price and our number sold. That takes care of our revenue. And now we just have to deal with our costs. Okay, so for our costs, we're told now it costs $3 per pound to grow the mushrooms. So we're going to subtract $3 for every mushroom, or for every pound of mushrooms we sell. Well, how many mushrooms do we sell? Well, we already talked about that over here, right? It's the 1,600 minus 100x. So our cost is 3, and then times 1,600 minus 100x. Okay, so right here now we have our equation for profit. And this is what we're trying to maximize. So we're trying to maximize the profit now. The maximum profit would be the optimal value, but we're not looking for that. We're looking for the price they should charge. So to find the price they should charge, we need to find the number of price changes. So we're actually looking for the x value that gives us the profit. So we're looking for the axis symmetry. So we've got to find the axis symmetry of this guy right here. Now, you might be inclined here, your first thought, to sort of expand everything out and put it into standard form, and then try and find your axis symmetry from there. And that will definitely work. There's nothing wrong with it. But what you might, if you can see this trick, this might be a little bit easier. You might notice here that we have our revenue and our costs, and each of them has this 1,600 minus 100 x factor inside. So we can actually take that out as a common factor, and if we do so, once we take that out, what's left over actually isn't too bad to deal with. So you got 1,600 minus 100x, and what's left over here is we got the 15 plus 2x from here. Okay, and we've got the minus 3 left over from here. Okay, so all this simplifies into 1,600 minus 100x. And then we get 12 plus 2x. Okay, so it did actually, without too much work, we actually have our profit equation in factored form. Okay, and again, if you don't notice this common factor that's possible right here, expanding everything out and simplifying to get in standard form will work perfectly fine from there, just to be able to find the axis symmetry from there, and we have many ways of doing that. But just keep in mind, this could be a faster way, save you some algebra. Okay, so now from there, to find our axis symmetry, from here we set the equation equal to 0, solve for x, we get x equals 16 for an x-intercept. From here we get x equals negative 6. Okay, so from there we want to find our axis symmetry. So x will be 16 plus negative 6 all over 2, so that gives me 5. And we have to be careful here. 5 is not the price, it's the number of price changes. So if we want to find the number of price, find our actual price that should maximize the profit, well, remember that our price was $15 plus $2 for every price change. So our total final price will be 15 plus 2 times 5, which gives me $25. So that's the price they should sell their mushrooms for per pound in order to get the maximum profit. Okay, so with that in mind, now let's try B. So we want to try and find how many pounds of mushrooms will generate $23,400 in profit. So thankfully we've already created our profit equation. We kind of started up here and then simplified it down here. So let me just take that equation, bring it down here. So we want to generate $23,400 in profit. So we're being told that our profit over here should be replaced with, again, the 23,400. We want to try to solve this equation. Okay, now here we don't have a choice, right? We want to try and solve a quadratic equation. We need to have 0 on the other side of the equation. So we got to expand everything out, simplify, set it all to 0, and then from there find our solutions. So I'll give you guys a second to try that algebra first. So pause it and push play when you're ready to see the answer. Okay, so here's the answer I have so far. Just to check our algebra, I expanded everything out here using an array, brought the 23,400 over, and then just tried to solve. So I factor out the negative 200 as a common factor. Is left with x squared minus 10x plus 21. This is a simple trinomial that happens to factor into x minus 7, x minus 3. So I get two possible solutions at x equals 7 or x equals 3. Now, remember, that's not actually our answer. That's the number of price changes. We want to know how many mushrooms will generate the 23,400 in profit. The number of mushrooms came from the fact that we had 1,600 pounds of mushrooms to start, minus 100 for every price change. So for each of our answers, we then have to actually calculate the number of mushrooms. So we're going to have, when x equals 7, 1,600 minus 100 times 7, which will give me 900. And another one at 1,600 minus 100 times 3. So always remember what you're actually trying to solve for. Don't just stop there when you solve for your x values, because there's still some work to go in this case. So this will tell us that there's two different quantities they could sell. They could sell 900 pounds of mushrooms or 1,300 pounds of mushrooms. Okay, and for the last one of this one, we're trying to find the maximum profit. So let's go back to our equation up here that we created for profit. Oops. Equation here. So there's our profit equation. We already discovered back in part A that the price that they would need to charge is $25, and that price occurred at an x value of 5 after 5 price changes. So x equals 5 is our axis of symmetry. We just need to sub that into the equation to then solve for the maximum profit. So let's throw that down here. Remember, that's our axis. Let's throw that in for x and see what happens. So we'll get p of 5. So 1,600 minus 100 times 5 is 500. And 12 plus 2 times 5 is 22. Okay, so let's run that through our calculator, see what we get. So it gives me 24,200. So that'll be our maximum profit. Okay, hopefully so far so good. We've seen a lot of word problems so far. Let's keep on going. A couple more left. So now we got the height of a foul ball. This one we were nice to give you the equation. So it's modeled according to h of t equals negative 5t squared plus 30t plus 2. We want to know how long the ball will be above 15 meters. So take a second to think about this one. If we want to know how long the ball is above 15 meters, it certainly helps to start by finding out when the ball is at 15 meters. So here it's giving us a height. So let's start with that. And I'm going to want you guys to solve this one. So so pause it and push play when you see the answer. And when you do this, I want you to go through and solve for everything. Try and find the whole answer. Okay, so you solved a few problems like this one before. So move the 15 over, have it all equal to 0. And then your options are to try and factor. Now, I checked the discriminant here. It's 640. That's not a perfect square. So you have to use quadratic formula if you want to get the solutions to this one. Use quadratic formula. You wind up with when you approximate two answers, 0.47 and 5.53, took 2 decimal places. Now, both of these are admissible because they're positive. We can't have negative times. It's not an issue here, though. Now, looking at our graph here, we have a parabola that's opening down. And if you look at the graph, there's a y-intercept of 2. So just to get a picture of what's going on, we have a parabola opening down, so a ball goes up, reaches some vertex somewhere, comes back down. So it's at 15 meters twice. We want to know how long the ball is above 15 meters. So we're looking at anything that's actually up here. So we're trying to find how long it goes. Well, we have the first time it reaches 15 meters at 0.47. The second time at 5.53. The difference in those times will give you the time it's above 15 meters. So we subtract them, we get 5.06 seconds. The ball is above 15 meters. Okay, so last one. So take a second to read through it. So you've got a parabolic tunnel, 6 meters wide, 8 meters high. We're going to have a truck that we're going to assume can drive down the middle, and it needs to pass through it. We're just wondering if it can fit. Okay, so I'm going to first try and sketch a situation here. So we've got a tunnel that's 6 meters wide. And 8 meters high. So our axis will occur somewhere at 3. And we've got a truck, so picture if you're looking straight down the tunnel here. I've got a truck that's going to try and drive down the middle. So I'll try and draw sort of like the view from the back here, and its best chance of trying to fit is to drive right down the middle. So it's 4.8 meters high, 3.9 meters wide. I'm going to try and center the truck around the middle here. So there's the truck driving down the middle. And we're wondering if it can fit. Okay, so just put some measurements on here. This truck right here is 3.9 meters wide along the base. And if you're thinking about where the truck's going to have the most trouble fitting, it's obviously going to be at the edges right here where the tunnel's not as high. So if in theory I could create an equation for this arch, and I can, we'll do that later, what I can actually try and do then is actually check at these particular x values right here, this one and this one or this one, at either one, see if the tunnel is high enough to cover the 4.8 meter height. Okay, so we've got a lot of ways to go to get there, but that's really what we're trying to do. So first things first, let's actually try and find the equation for the tunnel. So if I look at my graph, I've got my two x-intercepts here at 0 and 6, so I could build factored form. I also have my vertex here at 3, 8, so I could create vertex form. Doesn't actually matter, so you have your choice. I'm going to create vertex form. So I'll give me y equals a, some value I don't know, x minus 3 squared plus 8. Okay, and I'm going to sub in a point that's on this parabola, on this curve, on this tunnel, to try and get my a value. So I'm going to choose the point 0, 0, which occurs on the grid I just chose. So subbing in 0, 0, I get 0 minus 3 is negative 3 squared is 9. So continuing to solve, I'm going to get negative 8 over 9 for a. So that gives me my equation. Okay, now looking at this truck here, if I centered it, then it's 3.9 meters wide. If I want to find this value right here, well, if I take half the truck, so 3.9 meters divided by 2, that gives me 1.95. So that means that this distance right here is going to be 1.95 meters, which means my x value here, so moving up 1.95 meters from 3, is going to be 4.95 meters. So I'm going to check the height of the tunnel at an x value of 4.95 meters and see if it's actually going to fit my truck or not. So I want you to try that, and let's see what we get. So pause it for now. Okay, so when I subbed the 4.95 in the equation, I got about, or exactly, sorry, 4.62 meters for the height of the tunnel. So the tunnel's 4.62 meters tall, and the truck is 4.8 meters tall. The truck just simply won't fit. So that's going to be our conclusion there. So that's it, that's all. I've given you a worksheet that has tons of problems on it. I recommend that you do as many of them as you possibly can, just to expose you to a whole bunch of different types of problems. Okay, that's it for today, and good luck with the word problem worksheet. Cheers.